Maybe you know. Science meets the questions you never thought to ask. It's 2009. A man lies inside a humming fMRI scanner at Imperial College London. A nurse has just injected 2 milligrams of psilocybin into his arm. He's not hallucinating yet. He's about to. And as the seconds tick by, the most expensive camera in the building is recording something that will shatter 40 years of assumption. The man's brain isn't lighting up. It's going dark. Specifically, one part of it. And what they're about to discover will rewrite psychiatry. In 1971, Richard Nixon signed Psychedelics in a Schedule I. No medical value. High abuse potential. Conversation over. For 30 years, almost no one in a Western lab could legally hold a vial of psilocybin. Researchers at Johns Hopkins, Harvard, Imperial, they lost funding. They lost permission. The drugs William James and Aldous Huxley had once written about with awe were now banned chemicals, locked behind triple sign paperwork. But the question didn't go away. What were these substances actually doing inside the brain? Users described things that didn't fit our model. Ego dissolution. Time stopping. The walls between self and world melting. These weren't side effects you'd expect from a drug that just stimulated nerves. They sounded almost spiritual. The leading theory was simple. Psychedelics must overstimulate the brain. Why else would users see geometric patterns, feel cosmic, watch their identity dissolve? More chemicals, more activity, more weirdness. It made sense on paper. Then in 2006, the first legal psilocybin trial in decades opened at Johns Hopkins under a researcher named Roland Griffiths. He gave volunteers a single high dose. 2/3 of them later ranked the experience among the 5 most meaningful events of their lives. Nobody could explain why. 3 years later, in a London scanner, a young researcher decided to find out. His name was Robin Carhart-Harris, 30 years old, trained under David Nutt, the British psychiatrist famously fired from his government drug advisory role for saying ecstasy was less dangerous than horseback riding. Nutt didn't care. He gave Carhart-Harris a question and a scanner. The setup was almost absurdly clean. 15 healthy volunteers. Each one slid into an fMRI machine twice. First with a saline injection. Second with 2 milligrams of psilocybin, the active compound in magic mushrooms. The drug hits the bloodstream in 90 seconds. Effects begin in 2 minutes. Peak around 15. The scanner measured blood flow. More blood flow, more brain activity. The hypothesis was obvious. They'd see fireworks. Lit up cortex. A brain on fire. That's not what happened. In the first images Carhart-Harris pulled up, certain regions weren't brightening. They were dimming. Specifically, 2 interconnected hubs deep in the brain, the medial prefrontal cortex and the posterior cingulate cortex. The harder volunteers reported the trip hitting, the darker these regions got. The pattern was so unexpected, the lab went quiet. These 2 regions had a name. Together with a few others, they were called the default mode network. And it was about to become the most important brain story of the decade. To understand why, you need to know what the default mode network does. Picture your brain as a city. Most of the time, when you're focused on a task, driving, doing math, listening to someone, different neighborhoods light up to handle the job. But what happens when you stop? When you stare out a window? When your mind wanders? That's when the default mode network turns on. Discovered by neurologist Marcus Rakel in 2001, it's the brain's idle hum. It runs when you're not doing anything in particular. And what it does is essentially narrate you to yourself. It builds the story of who you are. It runs through your past. It rehearses your future. It maintains the constant background sense that you are a single, continuous person, sitting in a particular body, in a particular time. Some neuroscientists call it the ego network, because it's where your sense of self appears to live. In healthy adults, the default mode network is loud, dominant. It overrides other systems. In people with severe depression, it's even louder, locked in self-referential loops, replaying failures, predicting threats. And Carhart-Harris had just watched psilocybin shut it down. Quietly, completely, within minutes. But here's where it gets strange. When the default mode network goes quiet, it doesn't just mean the lights go off. The brain doesn't shut down. It does something nobody predicted. It opens up. In a follow-up study published in 2014, Carhart-Harris and his team mapped the connections between brain regions in both the saline and psilocybin sessions. In the saline scans, the brain looked organized, tidy. Visual regions talked mostly to visual regions. Memory regions to memory regions. Each network kept to its own neighborhood. The architecture of a normal mind. In the psilocybin scans, that architecture collapsed. Regions that almost never communicate were suddenly chatting like old friends. The visual cortex was firing at the auditory cortex. Memory was talking to motor control. Emotional centers were bleeding into language centers. Communication between certain previously isolated regions increased by more than 100-fold. The brain wasn't on fire. It was redrawing its map. This is why people see sounds, hear colors, taste shapes. Synesthesia isn't a hallucination. It's the brain temporarily without its old walls. And losing those walls felt, to many volunteers, like dying. In 2016, a team at Johns Hopkins ran what may be the most rigorous psilocybin study ever attempted. 51 terminal cancer patients, all of them with clinically diagnosed depression and anxiety. Lead researcher, Roland Griffiths. Co-author, Matthew Johnson. The design was double-blind. Each patient received one high dose of psilocybin, 22 milligrams per 70 kilograms of body weight, and one low, placebo-like dose on separate days. Neither the patients nor the doctors in the session knew which was which. They were monitored, talked through the experience, scanned, and tested. The results were so far outside normal psychiatric outcomes that the team checked them twice. 80% of patients showed clinically significant decreases in depression. 65% met criteria for full remission. And the most stunning finding, those effects didn't fade in days. At the 6-month follow-up, they were still there. For context, a single dose of psilocybin produced a larger sustained drop in depression scores than 6 months of SSRIs. For one experience, in one afternoon, what was the strongest predictor of long-term improvement? Not the dose, not the patient's history. The single best predictor was a specific subjective experience reported during the trip. Researchers called it ego dissolution, the temporary disappearance of the self. And just when you think we've figured it out, something stranger appears. That brain pattern Carhart-Harris saw, quiet default mode network, hyperconnected everything else, isn't unique to psychedelics. In 2015, neuroscientist Judson Brewer at Yale scanned long-term meditators during deep states. The pattern matched. Decades-experienced monks, eyes closed, hitting what they called non-self, showed the same fingerprint. Default mode dim. Cross-network communication soaring. It gets weirder. In 2018, a team led by Seelan Adesoy modeled the brain's connectivity under LSD. They compared the resulting pattern to brain scans across the lifespan. The closest match wasn't another adult brain on any drug. It was an infant, babies under 18 months. Before the default mode network fully forms, before the architecture of self locks in, the human brain looks, electrically, almost exactly like an adult on psychedelics. So when users say tripping felt like becoming a child again, like seeing the world for the first time, they're not being poetic. They're describing the literal neural state of a being who hasn't yet learned where they end and the world begins. The default mode network isn't just where the ego lives. It's where the ego is built, across childhood, brick by brick, and it can be temporarily unbuilt. Right now, as you watch this, your default mode network is humming. It's narrating the small voice in your head that just thought, "That's interesting," or "I wonder if that's true." It's the reason you have a name, a history, a self. For most people, that's fine. For some, it's a prison. In severe depression, the default mode network becomes pathologically loud, stuck, looping. Self-referential thoughts about worthlessness replay on a track that won't break. SSRIs, the standard treatment, work for maybe 60% of patients. Sometimes after weeks, sometimes never. That's why, in 2018, the U.S. FDA designated psilocybin a breakthrough therapy for treatment-resistant depression. 2 years later, in 2020, Oregon became the first U.S. state to legalize supervised psilocybin therapy. By 2023, more than 100 clinical trials were running globally. MDMA for PTSD. psilocybin for addiction, ketamine for suicidal ideation, LSD for cluster headaches. The Imperial College team has now treated over 400 patients. Some have been depressed for decades. After a single guided psilocybin session, many describe their lives as starting over. What changed in their brain? The same thing Carhart-Harris saw in 2009. The default mode network went quiet. The walls came down. And when they came back up, the walls were no longer the same. It's been more than 15 years since that man slid into the scanner at Imperial College. The injection, the dim lights, the cameras quietly recording one brain dimming where everyone expected it to flare. We thought psychedelics would show us a brain on fire. They showed us a brain dissolving its own walls. We thought ego dissolution was a metaphor. It turns out you can watch it happen in real time, region by region, on a screen. Marcus Raichle once said the most interesting brain isn't the one doing something. It's the one doing nothing, and what it does when you finally turn it off. Inside your skull, right now, is the network that tells you exist. It is essential. It is also a story, and sometimes, for some people, that story stops working. And sometimes, 2 milligrams of an old molecule found in a mushroom can rewrite it. Next time, we're going deeper into the default mode network itself, the brain region that builds your sense of self day by day from infancy onward. Why monks spend decades trying to silence it. Why people with split brain surgeries have 2 of them. And what happens when, in rare cases, a stroke wipes it out entirely. And patients describe a peace they'd never imagined possible. If you haven't yet, subscribe and follow the rabbit further. Thanks for watching. If this sparked a question, drop it in the comments. It might be your next video. We'll see you next time.